Solving systems of linear equations using matrices. Much like synthetic division helps with factoring, solving systems of equations using elementary row operations helps us find solutions that would otherwise be tedious or difficult. Take the system of three equations on the left here, for which there are three variables, x, y, and z. What we want to do is find values for x, y, and z that satisfy all three equations. If we view each equation as a row and we take the coefficients on the variables, we can write them as follows. For the first equation, we can take the coefficient of x, which is 1, and write that here. Same thing with y, we can write -2, and for z we can write 3. We draw a vertical line or dashed line for the equivalent, which is 9 in this case. On the next row, the coefficient for x is -1, so we write that here, followed by 3 for y. And since we don't have a z variable in this equation, we write 0, and then we write the equivalent on the right as we did before, in this case -4. For the third row, we use the coefficients of the third equation, so we write +2 for x, -5 for y, and +5 for z. Then on the right, we write the equivalent, which is 17. We can use the following method to solve the system of variables and equations. First, we note that only the row you're performing the operation on changes for each step. So in the case of the first step, we say r1 plus r2. Since the last term is the one you're performing the operation on, that is row 2, only that would change. So for example here, we say r1 plus r2. If we add the first row to the second, the +1 and -1 cancel out, and then -2 plus 3 is equal to 1, 3 plus 0 is equal to 3, and 9 plus -4 is equal to 5. On the second row here, you can see the result of operation 1. The 1, -2, 3 is equal to 9 stays the same for the top one, and we've changed only the second row. Before we go any further, however, let's clearly state what our goal is. Our goal is to convert what we start with to something called row echelon form. That means for the first row, you have all ones. Then dropping down to the second row, you have a leading 0 followed by ones. Then for the next row, you have two leading zeros followed by ones, and so on. Let's continue on with the problem and see where that gets us. So we've already done r1 plus r2, and we've gotten the result of that. Now let's do -2 times the first row plus the third row. If we do that, we get -2 for the first row on the first term, which cancels out the 2 on the third row to give us 0. Since r3 is the last term of our statement here, that's the row that changes. Multiplying -2 by -2 gives us a +4. +4 plus a -5 is equal to a -1. And -2 times 3 is equal to -6. -6 plus 5 gives us a -1. And we can't forget about the equivalents. -2 times 9 is equal to -18. -18 plus 17 gives us -1. So the result of operation 2 is that the first row doesn't change. So the result of operation 2 is that the first row remains 1, -2, 3, and the equivalent of 9. And that's because the third row is the one we're operating on. Now let's add row 2 to row 3. 0 plus 0 is equal to 0. 1 plus -1 is also equal to 0. And 3 plus -1 is equal to 2. 5 plus -1 is equal to 4. So the result we get of this operation is that row 2 remains 0, 1, 3 is equal to 5, and row 3 becomes 0, 0, 2 is equal to 4. Let's carry this over to the next slide here. What we have on the top is the result of operation 3. If you add the variables back in, you can see that what you end up with from row 3 is that 2z is equal to 4. So we know that z is equal to 2. If we add the variables back to the second equation, we get y plus 3 times z is equal to 5. If we fill in the value of z, which we now know, we get y plus 3 times 2 is equal to 5, which gives us y plus 6 is equal to 5. If we subtract 6 from both sides, we get y is equal to -1. So now we have the values of z and y. And finally what we can do is add the variables back to row 1, or the first equation, and we get x minus 2y plus 3z is equal to 9. If we fill in the values of y and z that we now know, we get x minus 2 times the -1, which gives us x plus 2, plus 3 times 2, which is 6, is equal to 9. That simplifies to x plus 8 is equal to 9, and if we subtract 8 from both sides, we get x is equal to 1. And now we found a solution that satisfies all three equations, and that is x is equal to 1, y is equal to -1, and z is equal to 2. Feel free to pause the video and fill these values into any of the equations above and confirm that that is indeed correct. Then take a break and come back and we'll talk about partial fractions.